Come on, tell me this. How are you, everyone?
What she said.
So yeah, your exam was really, really bad. Really, really bad. It was actually kind of disappointing. The lowest I don't remember, but the highest is I think 94.
That's crazy.
Nobody got perfect score. Nobody.
Did I at least pass?
Yeah, you passed.
Oh,
But most of the students failed. Most of you failed. Okay. So when you see your exam, you'll be really disappointed. And I think it's because of the no partial credit. The final exam will be exactly same like this one. There will be 30 questions, 24 of them no partial credit. You get only 6 questions partial credit. So see, if you don't get partial credit, either you get full credit or 0 credit. So 94, I think. Yeah, I'm going to give you an exam back at the end. And I'm also thinking what to do about the exam. But definitely there will be no carving. Okay. So I was thinking the best I can do for you guys, give you another exam on this Thursday.
Maybe I'll make up for this one.
Uh-huh. Uh-huh.
So what if you did pass, you have to take it?
No. If you're satisfied with your grade, you don't have to take it. But if you're not satisfied, then I can give you another exam. Not exact same exam and the same length. I'll give you only 6 questions for 30 minutes. Either full credit or no credit, no partial credit.
But fair question. Let's say this one goes bad. Question will go on the points list. The first one or the second one?
No, the makeup one, whatever you get on the makeup one, that will be scored. Or whichever is better. Okay. The first one or the makeup one, whichever is better, then you get that, keep that score. So yeah, and the makeup one, I'll give you only 6 questions, and it will be from your exam, not the same question. Okay. So in the exam, you have 9 questions with multiple parts. In the exam, I'm going to give you only 6 questions with no multiple parts. Only 6 questions, but 30 minutes only. Okay. And there will be factoring, solving, multiplying, dividing, the exponent, those things, but no partial credit, and I'm not going to give you more than 30 minutes. Okay. What do you think?
It'll be a regular class day, but like set aside 30 minutes for that exam.
So we'll have regular class, normal class, and then I'll end 30 minutes before. So if you are taking it, you'll stay. If you're not taking it, you'll just leave. But this Thursday. And I'm going to give you an exam after a bit when few more people come. Okay, so 7.5 talks about solving. In 7.3 and 4, we learned how to add and subtract. As long as you know how to add and subtract, that means you know how to solve. The difference between add, subtract, and solving is that when you add and subtract, you simply add and subtract, and whatever you get, you stop and then you leave. But for solving, in solving, you do add and subtraction, you get here in the last step, and then you set it equals to 0, and then you solve for the numerator, even the denominator. That's the difference between addition, subtraction, and solving. So we can actually solve in many different ways. One method here, it says first, you can get to the denominator, so you don't have to worry about that, but actually in real life, you do have to worry about that. So worry about the denominator first. First, find your LCD. And that LCD will tell you what you cannot have in the solution. So if you worry about the denominator at the beginning, then you can simply ignore the denominator and then work with the numerator only. That's one method. Another method is, well, bring everything to one side, add and subtract, like section 7.3, 7.4, add and subtract everything together, and then worry about the denominator. Denominator cannot be 0 because we don't know how to divide by 0, and we only set the numerator equals to 0. We factor solve for x. Okay. So these are the two most common methods we have. And so here, the two things you have to worry about is the denominator. What we cannot have in the denominator. In other words, what makes the denominator 0? You have to know that. And at the end, you have to make sure if you have those numbers in your solution, you have to disregard that. Okay? So let's do an example. Let me cross this out. Solve for x from this rational expression. So I'm going to show you the method I prefer. Bring everything to one side, add and subtract first. Why? Because if you know how to add and subtract, then section 7.3 and 4 will be easier for you. So instead of just erasing your denominator or ignoring your denominator, have your denominator, bring everything to one side, add and subtract, simplify, and then get rid of the denominator. Okay? So step 1, we want this on the left side. So we're going to subtract 8 minus x, sorry, minus 8 over x. As a result, this and this cancel out. On the left side, we have 3 plus 4 over x squared minus 8 over x equals 0. And now we are happy because we can see 0 on one side. And as I said before, whenever I say solve, try to see 0 on one side. If you don't see 0, at the end, you cannot set factor equals to 0. So you have a problem. So see your 0, bring it to one side, and now just like section 3.4, 7.3 and 4, add them and subtract them. So to add and subtract, we need to know LCD. What's the LCD between x and x squared? Good job, you remember that. So LCD between x and x squared is a bigger one, x squared. So we want to have x squared on every denominator. But the first one doesn't even have a denominator. We want to see x squared here. As a result, we have to multiply the numerator also by x squared. Multiply top and bottom by x squared. The denominator x squared is what we need. The numerator is because math is fair. The second term already has an x squared, so do you have to do anything on the second term? No. The third term has x only. So what do you need? Another x. So you multiply top and bottom by another x. And now we have x squared, x squared, x squared, all three denominators, they have x squared. We are happy, we write the denominator only once. And combine everything we see on the numerator. We have 3x squared. Let's bring the hx first. Minus 8x and plus 4. So we have x squared, x, and then no x equals 0. Guess what do we do next? Let's say I want to solve first. Let's ignore the 0 equals 0. If we had this, are you done adding and subtracting? You need one more line. How about the numerator? Remember I said anytime something is factorable, what do you have to do? Factor. So the numerator, is it factorable? If it's factorable, we have to use AC method. So let's think about AC. AC is 3 times 4 equals 12. Can you think of two numbers multiplied to 12 combined to negative 8? -6 and -2 gives you +12 and then -8. Perfect. So it is factorable. So let me use weird AC method. Weird AC. So in this weird AC, we have 3x squared minus 8x plus 4. We rewrite as x squared minus 8x plus what? AC, right? 12. And then we factor just like direct factoring. We have -6 and -2. But then it's weird, also another reason, because we have x times x squared, but they gave us 3x squared. So we need to put 3 on both x, but then the first one is divisible by 3. So we divide the first factor by 3, Matthews. Not 16, it's 12.
Oh.
Did I have 16? Why not 12? 8 times 3, so 3 times 4 is 12. So our factors are x minus 2 and 3x minus 2. So numerator is factorable. Let me write it here. X minus 2, 3x minus 2 over x squared equals 0. And now we are completely done with addition and subtraction on the left side. So we have to worry about the denominator now. We know denominator cannot be 0. So x squared cannot be 0. So x cannot be which number? If x squared cannot be 0, x cannot be which number? 0. That means if we have 0 in our solution, we cannot accept that. 0 cannot be a solution for our problem, this problem. Since we know what's wrong with the denominator, now we can get rid of the denominator. We don't need the denominator anymore because we already know what denominator cannot be. So we multiply both numerator. No, it's not working then. Oh, come on. We multiply both sides by x squared because we don't need the denominator anymore. We already figured out what denominator cannot be. So we left with x minus 2, 3x minus 2, and what is 0 times x squared? What is 0 times anything? 0. Now all we have to do is solve for x. So x minus 2 equals 0, 3x minus 2 equals 0. That gives us x equals 2, one solution. We add 2, so 3x equals 2, divide by 3, that gives us the second solution, 2/3. Fortunately, none of them are 0, so we don't have to worry about the denominator anymore. So step 1, bring everything to one side so that we can add and subtract, just like what we did before. Once we add and subtract completely, then we can worry about the denominator, saying denominator cannot be 0. So whatever we have on the LCD, we set that not equal 0, and then we solve for x to see what number makes the denominator 0. We cannot have them in our solution. And then we get here the denominator. Either we can visibly multiply both sides by x squared, or you can simply just ignore the denominator in the next step. From this step to this step, either you show multiplication by x squared, or you simply just cross the x squared on the denominator. Okay, it's up to you. The main idea is we ignore the denominator. So we only have numerator to work with. We set each factor equals to 0, solve for x. And if one of these x makes the denominator 0, then we cannot have them in the solution. Clear? Now let's do one example with something that makes the denominator 0. So let me skip all of these and come down here. So for x here, it says x divided by x plus 6 equals 72 divided by x squared minus 36. And then you're adding 4. What do you observe in the denominator? Factorable. So definitely we can factor this. What two factors gives us x squared minus 36? X plus 6, x minus 6. One thing I observed in the exam was, there was one question, 2 squared over 7 squared, something like that. Remember? Or 3 squared over 7, 3 squared. 3 squared over 7 squared. So it was like this, 3 over 7 square. Guess what? I got answer almost 25% of you answered. What's the answer of this? Both of them square, 3 square, 7 square. And then what is this? 9 over? 25% of you gave me the answer 6 over 14. Or 9 over 14. I was like, seriously, guys? I gave you these exponent rules many times, and you're telling me that 3 over 7 is like that 6 over 14 or 9 over 14. So careful, okay? I know you guys know the math, but when you write them, you actually don't write what you think you are writing. So be very careful. And another disappointing one was the first one. Like, man, x squared plus 36. 25% or 50% of you give me the answer. X plus 6, x minus 6. Remember, only if you have difference of perfect squares, then you can split them, then you can factor them. This factor for difference of perfect square. Is this difference of perfect squares? It's sum of perfect square. Then can you find the two factors as x plus 6, x minus 6? I said in the class, for class, there is no rule. So it has to be prime. It's not factorable because it's sum of perfect squares. It's not difference of perfect squares. Only if you have difference, okay? Anytime you see minus with two perfect number or perfect variable, then you can factor. For some, you cannot factor. And it was really disappointing that probably 50% of you gave me the answer is x plus 6, x minus 6. I'll give you the exam later. No, I just remembered this. I'm like, see, this is difference of perfect squares, so we can factor. If it was x squared plus 36, we could not factor. So step 1, we factor. Step 2, we bring everything to one side. Either bring the left to the right or right to the left. It doesn't matter, but bring everything to one side. So we have x over x plus 6. And you're subtracting the right side. So 72 over x plus 6, x minus 6. And you're subtracting the 4. So our right side is 0. So we subtracted this and we subtracted that. from both sides. So the right side becomes 0 and the left side has everything. And then we do addition subtraction. What's the LCD of x plus 6 and x plus 6, x minus 6? Both of them. So x plus 6, x minus 6. So we want this thing here, here, and there. On the first denominator, we have only x plus 6, but we want both of them. What is missing then? X minus 6. No, it's x minus 6. It's like parentheses. So first denominator has our LCD, we're happy. We're going to the second denominator. Do we have the second denominator? Do you have LCD in our second denominator? We do. So you're not going to touch that because we already have what you want. 4, it doesn't have anything. But we want x plus 6, x minus 6 on the denominator. That means you have to multiply the numerator by that. So we can combine all the numerators. X minus 6 minus 72. If you multiply these two factors, what do you get? See? If you multiply these two factors, what are you supposed to get? X squared minus 36. Because we factor x squared minus 36. So if you multiply the factor, it's supposed to get the original one, difference of factor squares. So this is x squared minus 36. So 4 times x squared minus 36. And then we do the distribution. But when you do the distribution, don't forget to change the sign because you're subtracting the product of these two. So let me write here. X squared minus 6x, x squared minus 6x minus 72 minus 4 times x squared, 4x squared. Now this minus 4 times minus 36 plus what? 144. So 36 times 4, 4 times 6 is 24. We put 2 on the top as an addition. 4 times 3 is 12 plus 3 is 14. And we have our denominator, x plus 6, x minus 6. We can simplify the numerator, right? We have like terms. So what do you get? How many x squared we have? X squared minus 4x squared. So when you combine, negative 3 x squared. And we have only one x, so 6x. And then we have two numbers, 144 positive and 72 negative.
72.
We get 72. Over the denominator. X plus 6, x minus 6. Numerator, is it factorable? What do you observe among all the numbers? 3, 6, 72. Hmm? They have a GCF. First of all, they start with something negative, so you can take out a negative. And then we know 6 is divisible by 3. All you have to know is 72 divisible by 3. 3 goes to 7 how many times? Twice. 3 times 6, 3 times 3 is 6, so we get 1 back. We bring down the 2, so we have 12. 3 goes to 12 how many times? 4. We have no remainder. That means we can divide 72 by 3. So if we can pull out a negative 3 as a common factor as a GCF here, we get positive x squared, positive 2x, and that's negative 24. It's negative because we have positive 72. We are dividing by negative 3. So it's negative 24. X plus 6, x minus 6 equals 0. Can you think of two numbers multiply to multiply to 24 combine to positive 6 and negative 4 plus 6 x minus 6 equals 0. What do you observe? Do you observe anything now? We're left with negative 3 x minus 4 over x minus 6 equals 0. Means we simplified fast, so we got you the problem we would face if we didn't use this method. Okay, so this method has one good thing is that in the simplification part, it gets rid of the extraneous solution. Means something that makes the denominator 0. We would get that in the solution if we didn't cross it out. Okay, I'm going to show you the details again. But here we cross out one factor. As a result, we have only one numerator, one denominator. So the numerator tells us negative 3 x minus 4 equals 0. And we know the denominator cannot be 0. So denominator tells us that x minus 6 cannot be 0. Numerator gives us the solution. Denominator tells us what we are not allowed to have. Negative 3 doesn't have any x, so we don't need that. So we just simply divide both sides. We get x minus 4 equals 0. That tells us our solution is only x equals 4. And we definitely cannot have x equals 6 in the solution. So if we had x equals 6 in the solution, we could not accept that, because that makes the denominator 0. Now, most people like to get to the denominator at the beginning, like here. Like here. Most people like to get to the denominator here.
So with the denominator, you don't have to solve x minus 6 equals 0, it's just x minus 6 equals cannot equal 0.
And then that gives us x cannot be 6.
Oh.
So what makes the denominator 0? You need to see that. So that if you have a solution that makes the denominator 0, you can disregard that. So let's say, you learned this in different method where you didn't have to work with the denominator. So if you didn't want to work with the denominator, you could get you the denominator here, or you could get you the denominator here the first step. Okay? Yes, you can get you the denominator, but the problem you face for getting rid of the denominator is that you're going to get a solution that makes the denominator 0. So let me show you a second method for the people who don't like to work with the denominator from the beginning. Okay? So I'm doing the same question, but using second method.
In the previous page, can we, no, the one before, without moving them x over x plus 6, can we just move that to the other side?
You get the same answer.
Then it should be positive 3x.
But here at the end, you're getting the, at the end, you're dividing both sides by 3. So it doesn't make any difference.
Oh,
Even if you have a -3 or +3, doesn't matter, because at the end, you need to get rid of that by dividing both sides. So does it matter?
and so you keep the x minus 4 by multiplying both sides by x minus 6, and you get rid of the x minus 6, the denominator, and then you divide 3 from both sides. Thank you.
So I see people who got to the denominator from the first step. Let's say you're among those who always try to get to the denominator because you hate the denominator. Yes, you can do that. So insert blank page, second method. Get rid. How many F we have on the off, on the get rid of? 1F or 2F? Off or off?
Yeah.
2F?
Yes.
Get rid of the denominator. Get rid of the denominator. So if you don't like denominator, you can get rid of that at the beginning. So at the beginning, we had what I forgot already, x plus 6. We had x over x plus 6. And then we have equals 72 x plus 6, x minus 6 plus 4. You can get you the denominator, but try not to do that. If you get you the denominator, you need to multiply everything by LCD. This way, you don't have to see the denominator. So plus 6 cancel out, plus 6 minus 6 cancel out. There is no more denominator left. You get x minus 6 equals 72 plus 4, x squared minus 36. So x squared minus 6x, 72 plus 4x squared minus 144, minus x squared plus 6x plus 6x. So one side becomes 0. And you can combine these two. So you get 3x squared plus 6x plus 72. See, it becomes very easy, right? The denominator, nothing to worry about. Take out 3, you get x squared plus 2x plus 24. And then this becomes x plus 6. No, I did something wrong, right? What did I do wrong? Oh, this is minus 72 because it's minus 144. So this is minus 24. So x plus 6, x minus 4. 462, 4624, yep. equals 0, equals 0. So 3x plus 6, x minus 4 equals 0. You don't need this 3 because it doesn't have any x. If any number doesn't have any x, you can get rid of that. So you get x plus 6 equals 0. X minus 4 equals 0. That gives us x is negative 6 and x is 4. So you get to solution once you get to the denominator. Now, remember, in rational, you always have to worry about the denominator. Even if you see it or don't see it, it doesn't matter. We have to worry about the denominator. Our LCD was x plus 6, x minus 6, right? So we know denominator cannot be 0. That tells us x plus 6 cannot be 0 and x minus 6 cannot be 0. Because this is our LCD, x plus 6, x minus 6. So LCD cannot be 0. Denominator cannot be 0. That tells us x cannot be negative 6 and x cannot be positive 6. Denominator tells us x cannot be positive 6 or negative 6, but when you solve the numerator, what solution you have? One of them is x equals negative 6. The other one is x equals positive 4. Can you accept both solution? Can you accept x equals negative 6 as a solution? You cannot, because negative 6, when you replace here, denominator becomes 0. This is what the LCD is telling us. If you have negative 6 in a solution, don't accept that. So you cannot accept this solution. So if you can remember to check your denominator, yes, this method is easier. Get to the denominator first, work only with the numerator. But at the end, you have to check what makes the denominator 0 if you have any of them in your solution. If you do, disregard them. But if you don't remember to check, then this is the best method for you. In this method, this cancellation helps you. This cancellation already gets you the problem we have. So you cancel x plus 6. That means you're not going to have a solution x equals negative 6 because here we cancel them. I guess understanding what I'm saying? So there are two types of people. Someone like to have a hard life, someone like to have easy life. So if you like to have an easy life, this method is for you. Work with the denominator. Get you the denominator at the beginning. But then you have a problem. At the end, you have to check all the solution you have. Does any of them make the denominator 0? You have to check that because you got you the denominator at the beginning. Now, the second type of people who like to have a hard life. This is the method for you guys. Simplify by bringing everything to one side, adding and subtracting. Once you simplify, you don't have to worry about the denominator anymore because this cancellation take care of the problem you're supposed to face. Okay? So if you think you're going to forget to check the denominator, stick with this method. Bring everything to one side, simplify, cancel, do everything.
How do you check
The denominator cannot be 0. So the LCD, whatever you have before LCD, the LCD cannot be 0 because LCD has all the denominators. So either you check every denominator individually, like what makes this denominator 0? What makes this denominator 0? So you check each denominator individually, or you just take the LCD and check what makes the LCD 0. For example, here, negative 6 makes this denominator 0. So you cannot have negative 6 in our solution. Now, for this denominator, negative 6 and positive 6, we cannot have both of them because both of them make the denominator 0. So see, just we observe the denominator, you see that you cannot have positive 6 or negative 6 as a solution. So once you have negative 6 is a solution, you're like, oh, we cannot have negative 6 in our solution because that makes the denominator 0. So we can check that. Here, no problem. Get you the denominator.
Not getting positive to that answer.
X cannot be positive 6 or negative 6 means it cannot have 6 or negative 6 as a solution. So this is the solution. The numerator gives you the solution. The numerator tells you it can have negative 6 and positive 4. But denominator says it cannot have negative 6 or positive 6. So they have a contradiction. Numerator tells us we are allowed to have negative 6, but denominator says, you cannot have that. So denominator works. For example, your mom and dad. Did you notice usually the mom wins? Usually, okay? In usual family. Where the dad is strict, then it doesn't, my example doesn't fall in that category. So this is dad and this is mom. Mom says you cannot have negative 6 or positive 6. I'm strictly forbidding you from his income. Dad says, hey, go to, I'm giving you negative 6 and 4. Since mom wins, still dad fails. We cannot have negative 6 as a solution. Because negative 6 is unhealthy. It makes the denominator 0, something undefined. So, love always, dad always loves us more than mom. I mean, it's not true. Dad shows more love than mom. So, dads usually let us do crazy things, right? But mom doesn't. So, this is something like this one. Denominator is like mom, it's strict. It tells us what we cannot have in our solution. Did it make things harder for you guys? Does it sound harder? Let's do one more example. Look at this example. What do you observe on the first denominator? Difference of perfect squares. So is it factorable? What factors we get? X plus 1, x minus 1. Now let's see what we cannot have in our solution. What makes the denominator 0? What makes this denominator 0? Negative 1. So you cannot have negative 1. What makes this denominator 0? X minus 1. What makes x minus 1 to be 0? Positive 1. So x cannot have positive 1. What makes this denominator 0? Positive 1. We already have that. What makes this denominator 0? We already have that. That means there are two solutions we cannot have in our solution. Negative 1 and positive 1. Sorry, there are two numbers we cannot have in our solution. Once you know what you cannot have, no problem. You can try any method. So which method do you want me to show you? The harder one or the easy one? Easy one. In the easy one, you don't have to worry about the denominator. Okay? So you can get you the denominator in the first step. Actually, it's not easy. Because once people multiply the numerator by the LCD, they keep canceling them and keep multiplying them. Like, it confuses them. So let me actually stick with the first method for the sake of 7.3 and 7.4. In 7.3, 7.4, you cannot get to the denominator. So why are you trying to get to the denominator here? Keep it denominator, okay? Combine them and then just get rid of that. That will be easier for you to do the addition and subtraction. So let me bring everything to one side. And this time, never mind. So 4 over x plus 1, x minus 1. minus x plus 7 over x minus 1 minus x minus 1 over x plus 1 equals 0. After this step, I'm going to get you the denominator, okay? So let's at least bring everything to one side so that we can combine them. What is our LCD? Both of them. X plus 1, x minus 1. Is there anything missing on the first denominator? No, so you don't touch that. We go to the second denominator. On the second denominator, we have only x minus 1. What is missing? So we multiply numerator and denominator by x plus 1. On the third denominator, what is missing? X minus 1. So we multiply numerator and denominator by x minus 1. And then we combine all of this. So 4 minus, let's do the multiplication here. And here. So we have x squared plus x plus 7x plus 7. In other words, we have x squared plus 8x plus 7. So x squared plus 8x plus 7. And when you multiply x plus 1, x minus 1, what do you get? Great. This gives us x bar minus 1. Observe, I'm putting the parentheses around them because we are going to subtract this. And in subtraction, we have to change the sign. So we are satisfied with the numerator, so we don't need the denominator anymore. So if you want, you can simply ignore the denominator. We are not actually ignoring, we are multiplying both sides by that, but you don't have to show that. Okay? That thingy and that thingy, they cancel out. So if you don't want, you don't have to show that. You can simply ignore the denominator. So you combine the numerator. And we are doing this because we already know that we cannot have these two numbers in our solution. We are having them in our mind. We cannot have them in the solution. So all these signs, they will change. We have 4 minus x squared minus 8x minus 7 minus x squared plus 1. We have to change all the sign because we are subtracting. Those data. So this is like terms. These and these are like terms. These two are like terms. We cannot cancel them because both of them have the same sign. So if you think you can cancel, it's wrong. It's not cancelable. So negative x minus, sorry, negative x squared minus x squared. What do you get? Negative 2x squared. And then we have only 1 8x. And we have 4 minus 7 plus 1. 4 minus 7 plus 1, -2. So 4 plus 1 is 5, 5 minus 7 is -2. So what do you observe? First of all, you're starting with negative. So you can factor out negative. And then if you observe all the numbers, what do you see? All these numbers are divisible by 2. So either you can take out -2 as a common factor or divide everything by -2. So let's say I'm factoring out -2. So you get x squared plus 4x plus 1. I did something wrong somewhere.
Did you not put the x plus 1 to the 4?
With the 4?
Yeah.
We don't have to because we already have the same denominator. So whatever has the LCD, we don't have to change that. So this is unchanged. We don't have to do anything here. This is x minus 1, so it's multiplying by x plus 1. So x squared plus x plus 7x plus 7. X squared plus 8x plus 7. And then we are subtracting x squared minus 1. So minus x squared plus 1. And this is 4. So 4 minus x squared minus 8x minus 7 minus x squared plus 1. Then what did I do wrong? This is not factorable, but we're supposed to have something that is factorable. Catch my mistake.
So,
Maria,
Only addition,
which one?
like, I see a little bit additions, there's no subtraction,
Where?
like, the original just addition.
But I wrote everything to one side. So minus this, minus that. So 4 minus this, minus that.
X minus 1, x minus 1, so then x squared minus 2.
Great. Because this is not difference of perfect squares. This is the same thing twice. So we have to actually multiply them. So this is x squared minus x plus 1. In other words, x squared minus 2x plus 1. Thank you, Martin. So this is x squared minus 2x plus 1. X squared plus 2x minus 1. So we have x squared minus 2x squared minus 8x plus 2x. So we get minus 6x. And then 4 minus 7 is minus 3. Minus 3 minus 1 is minus 4. So we have 1x squared, 3x, and 2. Now it's factorable. But we don't need the -2, so we can get rid of the -2 first. And we can factor this. Which two numbers multiply to 2 combine to 3? Plus 2 plus 1. So x plus 2 equals 0 gives us x equals -2. X plus 1 equals 0 gives us x equals -1.
but that's not really,
Exactly. See, -1 makes the denominator 0. So you cannot have that because you already figured that out at the beginning, what we cannot have in the denominator, or what makes the denominator 0. Now, x equals -2 is the only solution. Now in the exam, you're going to have multiple choice. X equals -2, x equals -1, x equals -2, -1. Okay? You have more choices, but definitely these three. So if you pick C, guess how much points you're going to get for doing all this hard work. If you pick choice C, 0. C says the answer is both of them. You got the answer both of them, but actually it's not true. Only one of them works, the other one doesn't work. So the answer has to be this one. That's why you have to check the denominator. Because if you don't check the denominator, you're going to pick C. That means you wasted your entire 15 minutes doing this. Okay. So I showed you 3 methods. In one method, bring everything to one side, keep the denominator. At the end, you can cancel the numerator with the denominator. That's the safest method. You don't have to worry about the denominator, what makes the denominator. The second method, get to the denominator at the beginning, but worry about the denominator. And this is the third method. At least have a denominator until you combine the numerators. Once you have the numerators together, then don't worry about the denominator. But still make sure to check what makes the denominator 0. So you always have to think what makes the denominator 0 anytime you are working with rational. If you're solving rational equation, you need to know what makes the denominator 0. Which number makes the denominator 0. And guess what? One of these will be in the final exam. The first one or this type? Mario. When x is -1, what do you get on this denominator? Oh. That's right. So in the final exam, we have one question either like this or something like the first one. Okay, definitely have one of these. So try this too. The answers are there, you can check. So try this too. And let me take the attendance. In here, Chris here, Axel here, Matthews here, Eliza here, Angel here, Honda here, Maria here, Ashley here, Exona here, Jason here, Kathy here. TK and Kayla. I get confused. Asim here, Kayla here, Krishel here, Calisius here, Mariam here, Kay here, Chanel here, Jasim here, Jonathan here. Wow, I have a perfect attendance today. And what do you have? You're like a baby. So I showed you 3 methods. Use whichever method you prefer.
I give you the zero. Boss.
Lost what?
Management constituent, and you know what makes the denominator zero. What makes the denominator zero? Zero. So you have to do a solution, so you're fine. How do you get for? One. So what denominator you want below one?
Square.
Right, so you do that. Oh, yeah, multiply and divide by x squared. So you definitely want x squared on the denominator, right?
Yeah.
As a result, it's multiply the numerator.
Okay, so
We need to find a way to get x squared, so I multiply this by x. And since this is not x squared, so I multiply this by x squared.
square plus x. Minus 7.
Okay.
So here
Here we go.
you want
So squared
X.
plus x.
so right
Zero.
here. So you're multiplying that by
Positive. Everything. Positive one. And explain everyone else.
So I can use it from or I can come. M1023. Right? No, your factors are not right. Because you have different sign there one.
Is it minus?
So which one you're? For this one, right? Minus 3.
One x, one x.
So 15 is 5. Plus 5 minus 2, what do you have? Plus 5 minus
That's how you have x squared.
so 1 to the 5 and 6x plus 7.
Squared. Minus 72.
So
I read you're right.
So 5
Minus 6 plus.
0. Yeah.
this could be
Yeah, no, he did two.
plus -1 positive 3.5. Why you're multiplying by x squared?
Yes.
If you multiply by x squared, then you have x cubed. But what is your LCD? X squared, right? So can you multiply by x squared? Let's see. And so for us. So ignore the denominator, so for the ignore the denominator, so when you want. But I just. You only found that they said each of them equals to yourself. You only need the highest one.
Yes.
And I just put your now stuff, that's. It was like. And X minus equals 0, so you have to multiply by x by something, because what is your LCD? X squared, but you x here. So you need something, right? Bigger one, but x is very bigger than x squared. So give me x squared.
No, no, I like.
So what did you do?
Okay, so when you multiply this is what x with the x here, right? So I will start x here and x here. So that we're gonna do the bottom and the top, and then I do the same thing here. And then I will do back here, come up with this here. I will get back to the here and the
And you're gonna be at the same denominator, this extra, then you are here. And then once you have this vector, that means numerator is simplified, so you can just ignore the denominator and numerator is. So this is it. So what makes the denominator is equal? Which number makes the denominator equal? 1 square is not 0. So what square is 0? Which number square is 0? 0. That means you know what 0 to the shape is. It's 0.
so x cannot be
And we have it would be that you have done because you know.
okay.
You're not done, right? Because once that means where denominator. You want which denominator below 1 threshold? So the multiple. And how can it be?
Alright, so you know how much no, I always get out with the number like all the so you multiply x plus x, if you just get your x. You also x squared, but one x here, say, no. And then the top here, which are
So step one is calculate space. That's why 72 becomes 5, then it becomes 1, right? So we just have yes, I think this one makes sense. This is so that makes it 72. So the first denominator,
and then I think that is 72.
square here, right? And then you can
And then I got I took the,
so we get x squared plus x.
and then you just
We then can subtract.
that's where.
Try this one. Yeah, it's only on one side. Great. So,
I don't know.
Usually don't see the x or x squared. That you see one x square and they're all denominator. So let's do this x squared here. That means you know only decimal. Yeah. So what are the two factors in that? Good. So now you can use a which asymmetrical. And then to use that. So asymmetrical, yeah. There are two weird things you do in the weird asymmetrical. The top one. Which one you want to use? The weird one or the regular one? And the weird one will be right as x squared, this, and instead of 3, this. And then factor regularly. Direct factoring. Then maybe the second year thing, you do it. Right, and then one of them definitely. And then you cannot multiply that square, you can multiply that square, and you got that here. You know, but you also get that square, right? If you want x square on the denominator, you have to multiply by one. You already have one, you want x square. Just that.
Yeah, I think everybody.
No, it's not.
Do you where with the point? So like x squared equals 2x minus 15.
I think it's fair.
I'll give it 5.
But you know, still with this. Why would you like to? Yeah, but how do you get x? You don't say even what you get x. You get x, right? 2 over x. When one times this x is x squared by what? Yeah, you have to multiply by x by x squared, right? So this is x by x squared. So this is squared. Then you have to calculate it. Why not the x squared? X squared and an s. What's the right?
How do we decide? Oh, you think it's?
Because one makes the denominator, I get this second one is denominator. Which number you, which number? Your x equals what makes the denominator one?
Oh,
We are doing a solution.
Oh, this one as well.
Is it not gonna be?
X divides 2.
You lost me.
X squared.
X square. Look like this.
5.
So you can like that, use that as factory.
Okay.
You can use that as factory, but you don't use that. Yes. So we are using that when we are speaking out there. You don't need to something. Since x and x squared, so you have to do it to 5 or 14. When we want 5x squared. But then 5 is 5 is 25x. So one of them has to be divisible by 5. Always. So this factor is equal to 5 divisible by 5. So you know, by 5 is this factor. Is 5 divided by 5 is 1. So 1 and this is you. These are 6 things. This is 5 brings and then you solve it. So one of them is you want
Oh, yeah. Okay, let's do them together. Bring everything to one side, so I'm subtracting 72x squared. So they cancel out. If you look at the denominator at the beginning, you don't have to do that. See what makes the denominator 0? Which number makes the denominator 0? Which number makes this denominator 0? Huh? Which number makes this denominator 0? 0. That means you cannot have 0 in the solution. So you decide, oh, x cannot be 0. Means our solution cannot have 0 in the solution set. So you have 1 over x plus 1 minus 72 over x squared equals 0. We already know what x cannot be, so you don't have to check by replacing because that tells us what you cannot have. Now, what is our LCD? X squared. What do we need on the first denominator to have x squared? X. So multiply numerator denominator. 1 doesn't even have any visible denominator, so we want x squared here. But then you have to multiply the numerator. The third denominator, do you already have the LCD on our third denominator? So you don't have to change anything. Now we combine all the numerators. We have 1x squared minus 72. And now you can ignore the denominator because you don't need that. You already know what makes the denominator 0. So you don't need that. Ignore. And rewrite the numerator. X squared plus x minus 72 equals 0. 2 factors that makes multiply to 72 combine to 1. Positive 9, negative 8. That tells us x plus 9 equals 0 or x minus 8 equals 0. So x equals negative 9 or x equals 8. And none of these gives us 0, so we accept both of them. If one of them was 0, we have to disregard that. But since we don't have 0 as our solution, we are safe. We don't have to worry about anything else. On the third one, we already have everything to one side, so we are happy. We just go for the LCD directly, x squared. No, because when you replace x with 0, you get 0 squared. And what is 0 squared? 0. But can you have 0 in the denominator? Same story is here. If you replace x with 0, you get 0 in the denominator. Not a lot. So here, what do we need below 5? X squared. So multiply numerator and denominator. On the second denominator, only 1x, but how many we need? 2. So how many more we need? 1. So multiply numerator and denominator. The third one already has x squared. We don't have to worry about that. So 5x squared plus 2x minus 3. We have everything on the numerator, so we can ignore the denominator. Ignoring means I'm actually multiplying both sides by x squared, so they cancel out. So that's why it means ignoring. So we left 2 with 5x squared plus 2x minus 3 equals 0. And now you have to use AC method because A is more than 1. Anytime A is more than 1, you have to use AC method.
5x minus 3.
5x minus 3.
1x plus 1.
X plus 1. Either use the normal AC method or weird AC method, but this is the solution. From here, 5x minus 3, 0 gives us x is positive 3/5. And from here, x plus 1, 0 gives you x is negative 1. And definitely one of these will be in the final exam. One of the thing, solving rational. Any question?
On the first one, when I plug -9 back into this equation, I didn't get, it didn't seem to work out.
That means you did something wrong? That means you did something wrong? 1/-9 plus 1 equals 72/-9 square. Right?
Yeah.
So 1/-9 plus 1, 72/, what is -9 square? 81. Now 72 and 81, both are divisible by what number? You can reduce them by, yes, 9. So you get what? 8/. So 72 is 8. 81 is 9. 72 -9, right?
Okay, no, it's right.
So we have -9. -9 square is +81. We have 72.
Okay.
We have 8/9.
1 plus -19 is.
So multiply by -9. We have -1 minus 9, and then -9. So -8/-9, negative cancel out.
Yeah.
8/9.
Thank you.
Did you find your mistake? What mistake you made?
Well, I don't know, it's a simple, like, arithmetic error.
That's why you don't have to check if you remember to see what makes the denominator 0. That's the main issue. Whatever makes the denominator 0, we cannot have them in the solution.
Yeah.
Okay, with this we are done with 7.5. I have few more questions, but I'm just going to ignore them. They are not important. Instead, I'm going to go to 7.6, and there's only 2 questions important in this section. 2 or 1? Two types of question important in this section, okay? One is working together, and another is both problem. But for the both, we don't use rational actually. We use system of equations. So why did they put this question in this section? Weird. So when we actually use the rational solution in our real life, something like this. Let's say few people are working together. So we have one person, Al. He can paint a room in 9 hours. The same room takes 12 hours for Bob to paint. So Bob is a slow worker. Don't hire him. You're going to lose money. And Al is faster. Now you got an idea. What if you put a faster worker and a slow worker at the same time to paint the same room? Then how long it will take? Will it take 9 hours or 12 hours or less hours? We want to see, like, we want to do an experiment. How long it will take to work together to finish a job if a slow person and a faster person work together? So in order to solve this type of question, the easiest way to solve this is by remembering one formula. The formula, where it comes from, I'm not going to show you. I'm just going to give you the formula because it's easier. The formula says it doesn't matter how many people you have. All you have to do is put 1/time for person 1 plus 1/time for person 2 plus 1/time for whatever many people you have equals 1/how long it will take if they work together. Now here we know first person needs 9 hours, Second person is 12 hours. So we know both of the denominator. We don't know this denominator, how long it will take if they work together. So anytime we don't know something, you put X on it and solve for us. So step one, use this formula to get one equation, one rational equation. This equation telling us our formula is 1/9 plus 1/12 equals 1/x. So we don't know, that together, they become x. Whatever you don't know, okay, that makes sense. That doesn't mean x is always on the right side. No, x is what you don't know. So if you don't know time for any person, x supposed to be in that place, okay? Can you remember? If you don't know something, it means it's x. You don't know it's x. So now it's a rational equation. To solve rational equation, you need LCD. So here, I'm actually not going to bring everything to one side. Why not? Because see, my x is already alone. Almost alone, right? The problem is on the denominator. We want to put in the numerator. So all you need to do is flip it, but not now. Once you simplify this side, then you can simply flip and you get your answer. That's why don't bring everything to one side here, because if x is already alone. All these examples we did, see, none of the x was alone. We have so many x's. So we need to bring everything to one side to have all the x together. But this case is different. In this case, our x is already alone. It's just not in the proper place. The since is already alone, don't bring it to the other side. Simplify this side and then just flip it over. Did you guys understand what I'm telling you? Okay. So what's the LCD between 9 and 12?
36.
Good job. So you want 36 on both denominator. So let me actually rewrite this equation so you can see. We have 1/9 plus 1/12 equals 1/x. And we know our LCD is 36. So 9 goes to 36 how many times? 4 times. So we have to multiply numerator and denominator by 4. Now 12 goes to 36 how many times? So we have to multiply numerator and denominator by 3. So if we add the numerators, we get 4 plus 3. So 7/36 is 1/x. See, x is already alone, almost alone. But we want this on the numerator. No problem, flip it. So you have to flip the other side. If you flip one side, you have to flip the other side. In this way, you don't have to do any math extra. This is 36/7. That's it. So you can flip only if you have one fraction on the other side. You cannot flip here because it's not one fraction. One fraction, two fraction. So flipping works only for one fraction, not for more than one fraction. Question? And that's what we have to do. And definitely one of these will be the final, definitely. So one of addition subtraction will be in the final, one of solving rational will be the final, one of real application of the rational will be the final. I'm already giving you 3 finalism questions. So try the next one. And then I have a last one. We will bring groups also together. Okay. 2 questions and then yeah, we're going to do the board question tomorrow. So you know that I have to. What if in the finalism you see it? Is it bad? It's supposed to actually fall under system of equations.
terrible question. Terrible.
Really?
I felt the question 3 different times. Yeah.
I think this question is the only easy board question. The question you're going to see in your homework, those are bad.
Say word. Say word. That's my grade.
There are two above 90, one is 93, one is 94. Yes, I'm not 93, one is not 94.
You're what? Dude, this is
This is what I got.
Yeah.
Is Thursday the makeup exam? The what? Oh, Thursday, I didn't do the exam. Yeah, makeup exam. Now we'll cover this exam. Oh. Oh, the symbol. Yeah.
So on this day, from this exam to give 6 questions. No multiple parts.
Are you gonna post the record sheet for this?
The exam. It will be from your exam. Not the same question. Wait, same type of question, but not the same. So the part doesn't have any parts, so it's just get to divide both of them by.
So just look at this.
Okay.
Right?
You're not giving it. No, it's not. She's in the back.
That's why I'm giving you these chance. There are only 110 chance.
Okay, she brought it down. Pretty much it down.
And these are these questions are unique from the exam. That's the same question, but same type of. Not here we have proposed two from any class. I'm going to give them one from one from one solving. So instead of 2, we have 1. Instead of 3, 1. Okay. And definitely the last question will be in this exam. The exponent one, definitely. Oh, this exam I actually did 2 things. If you solve it correctly, I graded your exam out of 100%. If you didn't solve it correctly, I graded your exam out of 96. Okay, so if you got perfect score, then it's 100% on your 100% scale. If you didn't get it, then it's on 96. Whatever you have, it's on 96. So I converted that into 100% scale. So actually, you punish you for the last question. If you have a complaint about the last question, you cannot complain because I didn't even give any points for that.
Wait, what?
The last question, if you did it correctly, then I counted. If you did not do correctly, then I did not count it. If you didn't do the last question correctly, your exam was out of 96 points. If you did the last question correctly, your exam was out of 100 points. So I didn't penalize you for not knowing the last question. But definitely the last question will be the makeup one. So study that. And now let's go over these questions. So remember, in the makeup one, I'm going to give only 6 questions from this exam. Not the exact same question, same type of question. From question 2, you have many factoring. I'm going to give only 1 factoring question from question 2. Only 1 factoring question.
So, Professor, The makeup exam that eliminates this grade and replaces it, or?
Replace, whichever is better. So if this one is better, you're gonna keep this. But if the makeup one is better, you're going to have the makeup one, the highest score. Whatever is the highest one, you get the highest score.
Thank you, Professor.
And no partial credit, either full point or no points. Okay? So I'm giving you a chance to improve your score. And I'm not going to give anything hard for the factoring. See, in this factoring, I already told you on the board which one has 3 factors. You're supposed to listen to me. Many of you got 2 factors for the 4th term one, but you're supposed to have 3 factors. So if you miss 1 factor, you get 0. But in the makeup one, I'm going to go into 1 factoring. So you're supposed to know your DCF, you're supposed to know difference of perfect squares, and you're supposed to know your factoring for all 3 things, 3 terms. Okay. So 1 of the factoring question will be in the final in this makeup exam from all those 12 factoring questions you have in your exam. Okay. So study the exam very well. Make sure you know how to solve each question. So you're going to see a similar question, not the same question, similar question, but nothing from the outside of the exam. Everything will be from this exam. Different numbers. So you have to know how to solve something. Exponentials, you should. So 6 questions, but 30 minutes only, okay? So you have to do them quickly. In the finalizer, you're going to have 30 questions, 2 hours. So for 6 questions, you're supposed to have 15 minutes to 20 minutes, something like that. In that place, I'm going to give you 30 minutes. And on Thursday, we're going to have at the beginning the normal class, and then I'm going to give time at the end. So on Thursday, you're going to have 5 minutes break after the exam, so after the class, 5 minutes breaks, relax your head, go to the restroom, and there will be no restroom in 30 minutes, okay? Even if you have to like hold it real bad, you have to do it, okay? If you pee here, no problem, pee here. But now I'm telling you guys, like, you guys have an excuse in every exam, oh, I have to go to the restroom. But in this exam, you cannot go to the restroom. It's only for 30 minutes. So 30 minutes, you have to use the restroom before the class, before the exam starts, finish everything in 30 minutes, and then go. Okay? Thursday, this Thursday. In the next Thursday, you have your actual exam, the 4th one, in next Thursday. So you have 1 exam this week, another exam next week. And now let's do these 2 together. The first one says Debbie can prepare in 9 hours. So 1 person, I don't have the answer here. I don't remember the answer. So 1 person takes 9 hours. So 1/9. Jessica prepared the same dinner in 6 hours. 1/6. And you always add them, okay? Add all the people. And then Sal can prepare the same dinner in 4 hours. 1/4. How long it will take if they work together? So do you know how long it will take if they work together? We don't. So it's X. Whatever you don't know, it's X. That means you need to know the LCD for 9, 6, and 4. Again, 36. So 9 goes to 36. 4, so multiply top and bottom. 6 goes to 36. 6. And 4 goes to 9, you already know. So we have 4, 6, and 9. If you add all of them together, how much we have? 4 plus 6 plus 9. 19?
Yes.
So 19/36 is 1/x. That means what is x? 36/19. That's it. That's all we have to do. Now the next one, the last one. 1 custodian cleans the office in 4 hours. So 1 person takes 4 hours. 1/4. When the second worker asks to join with the regular custodian, it takes 2 hours together. So this time, do you know how long it will take if they work together?
Yes.
2 hours, so it's 1/2. So together is 2. How long it takes for the second worker to do the same job alone? So do you know how long it will take for the second person to do the job? No, means this time X is on the middle. The second person, we don't know how long the second worker takes. So whatever you don't know is X. Now this time X is not alone. So we want to get to the 1/4 to bring it to the other side to get the 1x alone. Because if the 1/x is alone, we can simply flip it to get the upside. So we don't want this 1/4. So subtract this 1/4 from both sides. So 1/x is 1/2 minus 1/4. And now we're happy because our x is almost alone, almost. Now what's the LCD this time? 4. That means we need to multiply this denominator by 2. So we have 2 minus 1 equals 1/x. So 1/x is 1/4. That means what is x? That's it. That's all you have to do. And this will be the final result. So see you guys tomorrow. Have a good day. Have a good day. The test is extra. So if you're already satisfied with whatever you have, you don't have to take that exam.
Well, I walked out, guys, like.